GOAT, the generic online annotation tool. We are Team Alpha Helix. I'm Aaron.
I'm Ben.
So our sponsor for this project was Phoenix Bioinformatics. They are a nonprofit based in the Bay Area, Fremont, California, and they are dedicated to the sustainable support of scientific data. We were lucky enough to be able to have Ben visit them during spring break, as you can see from the picture up there. So Phoenix came to us with a problem. They needed a system that they could use to handle submission, curation, and export of all of the scientific data that they manage. It has to be easy to use so they can get more researchers on board. It had to be able to work for all organisms. Their current system, Toast, was not very usable. It only handled the submission portion of the process. They required another tool for curation, and it was only for one organism, Arabidopsis thaliana. So last year, another team took on the task of creating this system for them. They handled most of the back end, most of the database work, and they set up part of the submission workflow. But the UI was sort of proof of concept. When the project came to us, we had this list of requirements with the top two, improving the UI and the UX, and finishing the full submission curation workflow is kind of the top ticket items that we needed to complete, along with some extra things, especially the exporting of data. Previous team left us with this architecture with Node and Express in the back end, communicating with a Postgres database, and the front end using React and Redux. Over the course of this year, we added some improvements. We added Bootstrap to the front end to make it a little bit easier for us to iterate and improve on the front end design. We cleaned up the unit tests in Mocha and Chai, and we added a Travis CI continuous integration pipeline, which uses the unit tests to make sure the build is working before deploying to AWS.
So now I'm going to talk a little bit about the domain behind GOAT and why Phoenix wanted us to make it. So if you're a researcher, you've published a paper and it's been peer reviewed, and you now want to extract sort of this data, the insights that you've gotten from the paper in a common interchange. So things like this gene does this, or this protein interacts with another protein. And when it's just a plain text, PDF, it's really hard to parse through that. So they want to make kind of these almost like an abstract knowledge graph of these kind of interactions. And so what the researcher would do is they would go to this, they would go to GOAT, go to the submission, and they would enter in this gene does this, and here's how we know it. And that kind of builds this kind of foundation of knowledge for all these claims. Everything that they type is actually validated against external databases, so that they're not just saying that they're not just making things up effectively. They can suggest new terms as well that curators can then suggest to the governing bodies. So that portion had been sort of completed by the previous team, and so we sort of took the other half of that, which is the ability for biocurators or people who work at Phoenix to make sure that the things that the researchers are saying in their submissions is true. That they are, that there's no typos, or that they really meant this other, method or term or something like that, and really just make sure that the data is good. And so this is the process of curation. They can accept and deny and edit all of the information that the researchers enter. And finally, we can export the data into this common interchange format known as the Go annotation format. Basically serializes everything, all the accepted data, and then other databases and other biological systems can ingest this and disseminate the insights. So now we're going to kind of go a demo of what this actually looks like for researchers and curators. So we have a prepared video demo. If it would full screen. Well, that's fun. And we tested this. Okay, we're just going to look at it like this, unfortunately. So here's the submission page. You can see that the page has already been preloaded with information from the last time that the submitter had gone through. They can enter in detailed information about a certain gene and go down to this annotation that they had already started. So they can type in any function, and we have a nice autocomplete here. They can search by term, synonym, a bunch of different things like this. You can see right here, the user forgot to enter in a method field, and so we give them a nice little warning. And they can enter in the right thing. This is evidence with. It was just another feature that we had to add to the database, which says that this gene interacts with this other thing here, effectively. This is just a nice review page. And now they've submitted it. So now they've basically told the curators that this is kind of the submission from the paper. Everything's like sort of, each paper contains a certain set of these annotations. And now we can go and, as a curator, so this would be somebody working at Phoenix, would come in here and look at all the data that the researcher has entered. They can approve, deny, and edit. So they approve this one. That's like, wait, actually, this is meant to be a different term, and they can go in and edit it. And then effectively say, look, everything looks good. Sounds good, and they can finish. And congratulations, there's now, will be able to be exported. And so now the annotation will show up in this sort of export file. And then we do nightly dumps of that. This is just an admin page that allows them to edit users and allow people to be curators or admins. And effectively, this is the main tour of the system. So I'm going to turn it over to Gavin.
So over the past 2 semesters, we faced a few challenges involving the domain knowledge and onboarding for the existing system that we came across. So managing those challenges were one of the primary things we focused on in the first semester. You can see that just learning like the schema took us a bit of time in the first semester, and we had to learn how to manage the scope of our MVP in order to deal with that with a smaller team size. Some of the positive things that we wanted to look back on was we had a good interactions with our sponsor, and we were able to have user testing with real users that are knowledgeable in the field and get feedback on what worked and what didn't. And that allowed us to have good iteration and improve the product over sprints. Another thing that we tried to do to improve our workflow this semester was communicating through Slack for daily stand-ups. And by doing that, we were able to work more independently and be more productive. And we were able to meet the MVP goals, which is great. So here are some of the metrics that sort of show that that dynamic between the first 2 semesters. In the top chart on the left here, you can see that in the first semester we were working a lot of hours, and that largely has to do with the domain knowledge onboarding and as well as just the tech stack onboarding. We were able to become more efficient in the second semester by managing our time better and creating more granular issues. And as you can see in the bottom chart, we became more productive in that way during the second semester. Some future work that we think would be great for the system includes searching and browsing functionality of the submissions made by researchers, as well as a user profile page to manage the researchers or curators' information, additional validation sources for relations and functions, as well as being able to export to different formats that other databases and systems can work with. Any questions? Yes.
Can you tell us about what you learned from user testing at all?
Sure. So one of the things we did was when we were rewriting the UI in Bootstrap from the old team, we tried a couple different things, like a wizard view where we'd step through one, like enter just the publication, then do your genes, and then do the other thing. But we found that without seeing everything up front, that people like were kind of confused on the relations between kind of the things. And it was too confusing having the whole page move, and going back and forth was a big thing that we learned. We did validation too. There was not very good validation, like why the form wasn't submitting for a while. And recently we got some pretty good validation messages and tooltips, which I think greatly improved the usability of the system. So.
You made mention of your performance improvements. I was just wondering if beyond Slack giving you a chance to communicate, what other things do you feel went well? You know, was it just a pressure deadline or?
So Gavin made mention of the fact that in the second semester we also did more work to break down our tickets more accurately. One of the things stymieing our issues closed in the first semester was having too many like epic size tickets and not being able to close those in a reasonable amount of time and break down the work needing to be done to actually count it as completed. So being able to break it down more accurately and get a picture of the individual steps to finish our larger pieces of work was instrumental in being able to finish these tasks quicker and more effectively and have defined acceptance criteria to increase our issues closed.
We also started using the Kanban board provided by GitHub Projects more directly with our sponsor. Instead of just for us, like for what we're doing, we look during our meetings and be like, okay, we've completed this, we've done this, and that increased visibility was really helpful, I think, too, in our second semester.
Just a follow-up. Did you get a sense for, you know, when you're accomplishing things and your teammates are accomplishing things, kind of get into that momentum? Did you sense that with the granularity of the test?
I would think absolutely, yeah, because we felt, you know, like when you have these big epics, it's like, okay, we need to do curation. If that was one issue, like that thing requires so many, like, you know, definitely we when we fall in line with all the smaller things, it was able to be, we were able to convey, you know, a better sense of our accomplishments. Yep. Oh, yeah.
Did any of you have background in biology before?
So my application domain is bioinformatics, and that was the main reason why I chose this project to begin with. It seemed like it had an interesting tech stack, and if I wasn't a software engineer, I'd be doing something with biology, so I feel like this was a good crossover.
And what did you use then to learn the biology that you needed?
Well, a lot of, like, some of the background from my bioinformatics classes definitely helped me with, you know, like all the base terms of like the genes and the locuses and how that kind of all works together. But a lot of it was just really just talking with our sponsor and really just, you know, like having a lot of discussion with them for the things that they needed. So, yep.
So, is bioinformatics actually going to use this tool? And if so, how have you handed off what you have done today in a way that will be capable of technically so that they can continue their career?
So, yeah, the goal is for them to use it in production. We wanted to get it to this MVP state where they could start testing it with real data and real users by the end of our our semester. We currently deliver to them on AWS. They have an AWS instance. The project's actually all open source. It's all on GitHub, which is really nice. So they'll always have access to the code. They have the AWS credentials, and we added, as we mentioned earlier, we have continuous deployment. So any future team or any person who merges into the master branch, it gets deployed, and it's all maintained. They have all the keys and stuff for that. So hopefully they'll be able to deploy it and use it in production as soon as they feel it's ready. So, any questions?
Thank you.
All right, so we are Team Reefer Madness, and our project sponsor was Carrier Transicold. My name is Jake Doolin.
I'm James Ward. And I'm Mitchell Derby. And our coach is Rick, and our sponsor was Paul.
All right, so what we're going to talk about today, we're going to start out with the context, give you guys a brief overview of any of the background information you need to understand our project and our project domain. We're going to talk about the requirements that our sponsor provided us, and then we will jump into the design. We'll get into some of the technologies we chose for our project, as well as some of the design trade-offs we had to consider. Then we're going to jump into a demonstration of the product that we built on several different mobile platforms. After that, we will get into a reflection of our project, what went well and what could have gone better. And lastly, we will talk about the future and what the team next year could do to improve upon our project. So let's start with the problem that our sponsor wanted us to solve. Our sponsor is Carrier Transicold, and what they specialize in is refrigeration units for shipping containers. Inside these shipping containers could be various goods, food, medical supplies, really anything that needs to be regulated at a certain temperature and humidity. So there are a variety of sensors inside the reefer, and sometimes there are issues with these sensors. Sometimes the temperature or humidity or valve pressure or whatever could be out of range inside the reefer, and in this situation a reefer technician would have to physically connect to the reefer via a USB connection. There is no ability currently in the field to connect to a reefer wirelessly. So there are hundreds of sensors and actuators inside the reefer, and there could be up to $1 million in cargo inside this reefer. And it's a shame that none of the technicians could diagnose this easily wirelessly. So here's some pictures of some technicians actually physically connecting to the reefer to give you an idea of how complicated and how much this could be improved if these technicians had an app that was able to wirelessly connect. So early on in our project, our sponsor gave us a codified list of requirements, and they were actually pretty easy to understand. They wanted us to connect to one or more reefers via Wi-Fi. We needed to build a mobile app on all three major platforms, iOS, Android, and Windows. And this app needed to provide the technicians the ability to connect and monitor sensor data in real time, as well as graph that data in real time and export it into a CSV file as well. They also needed to be able to see any active alarms, any sensors that were out of range, or anything like that.
So next we're going to talk a little bit about the design. So start off with technology. So we built an app using Ionic. We're using SQLite for our database. We're using TypeORM to communicate, make it easier to communicate with the database. And we're using Plotly, which is a JavaScript library for graphing. So Ionic is a hybrid development platform. So basically, it gives you native functionality on mobile devices, but also uses web technologies. It's built on Angular, so you can build a very responsive UI and still use native app function or native phone functionalities like camera and things like that. So some design trade-offs we made. First, going with the hybrid app approach instead of building a native app or something that is fully native. It helped us create a much more responsive UI and have faster development. Although going into it, we knew that we might have some performance issues that we would have to diagnose because we're not using a fully native app. One of the other trade-offs is we wanted to, when we were polling the reefer for sensor data, we wanted to be able to do this on a separate thread. And we were going to potentially use a service worker, but we were not able to get that working inside Ionic, and so that was a little bit of a performance hit. And then lastly, sensor data types. Currently, the way sensors have types assigned is that there's basically a list of types, and that each sensor can have any number of the types. So a sensor will have potentially a a type that means, oh, it's an alarm, but then it'll also have a type that indicates that the data that is expressed by this alarm is an unsigned byte, or let's say if it was a temperature sensor, it has a float. So instead of we could have used hierarchies, but this let us be a little more flexible, but it's a little harder to manage in terms of changing things. So a little bit for the system architecture, just to give you a little more background. So Ionic uses Cordova to access the native functionality on the phone, and then it uses Angular, which you use to build the front end. And this all compiles down to an app that you install natively on the phone, and it uses your web browser render essentially to render the app.
Okay, so now we're going to get into a demonstration. We recorded our demo because we wanted to be able to show you guys our app running on multiple different devices. So we're going to start off by demonstrating the connection to the reefer and how that UI flow works. So on the left you see an iPhone X, and on the right you see a Pixel 2 XL running the latest versions of iOS and Android. So we're going to go in here and we are going to connect to a reefer. This is just showing the basic hamburger menu opening and closing on both devices. And then we will click reefers to begin to connect to a demo reefer. So we click view here on both devices and then connect. And we enter in the password. Since this is a demo reefer, we can enter any password. So I just typed in A, and then we click login. And then you are presented with the reefer detail screen, which shows all of the various actions that you could take with an individual reefer. You could view the dashboard page, you could view the graphing page, CSV export page, and you can toggle whether the app is currently pulling data from the reefer. Next up, we will show you how to actually favorite sensors. So we're going to go into the dashboard page. We're still on the iPhone X and Pixel 2 here. So this is our dashboard page. We have 4 rows, and here's our sensor select list, which shows all of the sensors that we have that we're currently pulling. So we added one sensor to the top row there on the iPhone, and then it shows up there. It is pulling data every few seconds, and then we do the same thing on the Android phone. Throughout this presentation, you'll notice that on the Android device, it's running much slower, and this is because Android has an emulator instead of a simulator, and you'll notice that my CPU is like going through the roof right now because this pretty much kills it. But as we're going through here, we're just adding more sensors, so now we have 4 sensors on the dashboard, and they pop up pretty quickly on iOS. The thing about these rows is that you can add up to 3 sensors per row, so you can configure multiple sensors in each row. Here we're adding 2 more sensors to the top row, and then 1 more sensor to the bottom row, and we'll go back and show what that looks like. And then we'll add some more sensors to the Android side of things as well. I'm just going to skip over that because it's not important. And we can also remove sensors from the dashboard by clicking on an individual cell and then tapping remove. You could also remove sensors by going into the sensor select list and tapping on one of the icons that is blue and then clicking remove from there as well. And yeah, you would notice that the sensors took a while to load on Android. That does happen much faster on a physical device. In the emulator, it's a little tricky. Next up, we'll show you the graphing functionality, and this will be shown on an iPad Pro and a Pixel C. Also in landscape mode, so that you can see that the app works fine in landscape mode as well. So when we first go to the graphing page, we can see that we're not currently connected to a reefer. So we go in back to the original flow that we showed before to connect to a demo reefer. And then once we are connected, we can choose certain sensors to plot, and we can see the data visually on the graph in real time. So now we're connected, and we have a list of sensors to choose from. We can select 3 of them here and go back. And then while those are loading, we could go over into the Android tablet and connect to a reefer over there and load up some sensors as well. So sensors could be added and removed from this live graphing display at any time. And here we're going to add 3 to the Android tablet, and then we could add 1 more to the iOS side. This is all dummy data because it's difficult to connect to a real reefer in the emulator. We do have that functionality working right now on devices. You can actually connect to a real reefer on an iPhone or an Android device perfectly fine. It's just difficult to do in the demo. So that was the graphing functionality. And then lastly, we're going to go over the alarms, the CSV export, some settings, and then disconnecting from a reefer. So this was actually recorded on a real device. This is my personal device. That's my background. That's the app. I only have Reeferline and Spotify, the only apps that I have. So we're going to open this up now. And we're currently connected to 1 reefer. And then we're going to click the alarms page to see what the active alarms look like. Right now there's 9 alarms going off in this reefer. And all we had to do was show, what alarms were going off. That was the only requirement. This is the CSV export functionality. So here we're selecting reefers that were selecting sensors that we're currently polling, and then we're going to do a CSV export. So the requirements were that we would just compile a CSV file and send it over email. So here I'm opening up my email that just got sent. Right now in this demo, this is actually a .txt file. Today we pushed up a commit to change that to a CSV, but it is formatted in a CSV here. Same thing. And then when this is over, we're going to go back and show you some of the settings, what the settings page looks like in the app. So we can click settings, and here we can toggle different units to display. It's currently set to Fahrenheit. So on the dashboard, we're displaying Fahrenheit, and then we just switch it back to Celsius. Yep, that's all that is. And then lastly, we can show how to disconnect from a reefer. So we can see that we're currently connected here. We click disconnect. And then when we go back to the dashboard page, you can see that the sensors are no longer polling and there are no more active alarms.
All right, so let's talk about what went well and what went not so well in our time on this project. Firstly, the good. Ionic was a good technology choice for us. Originally, we planned on using React Native, but after a couple of weeks down that path in the first semester, we opted to switch. One of our team members had experience with Ionic, and it ended up being a much better choice for us as a technology. Mitch touched on the fact that developing 3 native apps would take a lot longer. So in terms of development time, this was a really good option. And performance was really good for us for this project. We were worried a little bit that because it's not a native app, it might have some performance hangups, but for the most part, it's been really good. When we finally added in all the sensors and had a full reefer system running in the back end, we did see some performance drops, but we've been able to optimize it and mitigate that, and yeah, we're really happy with the result. Secondly, design to schedule was a really good methodology choice. It let us line up our plans and our schedule with Carrier's internal development team, so as they brought more hardware online, we could integrate it with our system. It also meant that we prioritized the UI as the first step in the project, and that meant we had a working prototype for our sponsor to look at since very early in the lifetime of our work. Some not so good things. Unfortunately, one of the last plugins that we added to the system was a TCP connection plugin, and it doesn't work with the Windows platform. So that means that currently we do have full functionality for iOS and Android, but Windows is not fully functional. We couldn't find a plugin that would accomplish this for all 3 platforms, so if a future team was to come in, they would need to port the plugin or write some code themselves, native code, to the, in Windows. We also only had 1 hardware board, and that meant that only 1 person could be working with a real-world device at any given time. And Mitch stepped up and really got good at understanding how to use the board and did a lot of the work there. We had it for a number of months, so we're happy with the result, and we definitely got to use it to its full extent. Finally, some of the implementation changes that we had in the project pushed us back a few weeks. The first one being, like we said, React Native versus Ionic. That moved us back a couple weeks. Also, some implementation changes and misunderstandings on our end about how certain systems would work, like pulling information about the alarms, meant that we had to backtrack just a little bit to get those working. I think the biggest change that we had was when we went from hard-coded data to real like database entities and a full working system in the back end. We did have to rewrite a lot of some of the code to get that to line up with our front end. And finally, the future of the project. So, first of all, we produced some documents throughout the life cycle of the project. Requirements document, design document. These will be delivered to the sponsor at the end. Along with that, we're currently compiling a list of known issues to give to the sponsor. That'll be a description of what the issue is and how they might be able to mitigate it or fix it. And finally, we'll have a comprehensive document of build instructions, debug instructions, as well as some guidance and some information about how to use Ionic, how our system is set up so that a future team can jump in and get started. And if a future team is to jump in and get started, then these are some of the things they'd be working to complete. First and foremost, carrier wants the ability to connect to multiple reefers. Currently, the system connects to a single reefer via the reefer's Wi-Fi hotspot. Carrier would like a system that allows reefers to be connected to a Wi-Fi network and the app to connect to that network and pull sensor data and alarm information, what have you, from some or all of those reefers that are connected. So this was a stretch goal, so we didn't get to it, but it's definitely something that could be added to our architecture. We definitely have things in place that would allow this to be possible. Secondly, there's something called pre-trip tests. Basically, before a reefer is put into use, an engineer wants to make sure that the sensors are working, the alarms are working, basically run a diagnostic test on the reefer. We don't have this functionality in our app, but this also was a stretch goal, and this is also something that could be done by a future team. If you had both of these working together, then you could theoretically do pre-trip tests on a whole host of reefers at the same time. This would be a really big time save for Carrier and would be great to have in the app. And finally, like we mentioned, Windows support Windows is not supported right now, but the only thing holding that back is really that single plugin, so a team in the future would not have much trouble coming in and making that final stretch to make it work for all three platforms. And that's it. Any questions? Yes?
Did you find you had to do much reverse engineering in order to answer, how things would work?
There were definitely a couple of places where we had to kind of reverse engineer, particularly when it came to the sensor layout of the when actually communicating with the hardware and the responses we were getting back in terms of how the message was constructed and things like that.
Is there any security concerns? You mentioned having a log on. Is there anything else beyond that that you need to think about or should be thought about?
Currently, that's not in the scope. That wasn't in the scope of our requirements. I'm sure it's something that Carrier will want to consider in the future.
So essentially, when you connect to a single reefer, the way that works is the reefer puts up its own Wi-Fi hotspot, and so you have to, on your phone, authenticate with that. And then after you do that, you go into the app and you authenticate to access the API for that. So there's authentication to both get on the network and then also to communicate.
Yeah, but in terms of like someone having a profile or having like a login and password, that's not included.
From the looks of the app, it seems like Cordova does a good job at, supporting a fairly consistent UI. At what point did you kind of realize that you go with Ionic or some other master library as opposed to the initial stages that you were going through?
Well, writing 3 native apps for us was, I think, kind of always off the table. From the very beginning, we knew we didn't really want to do that. We thought React Native would be the best choice in terms of a cross-platform solution. But that was early that we chose React Native, so a cross-platform solution was always an intention. It was after a few weeks working with React Native that we realized we'd get a lot more mileage out of Ionic.
All right, let's thank the team.
Alright, we're Team PTP Team Plus. Our project was on the Precision Time Protocol. I'm Brian Traub. I'm here with Josh Jarvis and Kevin Hannigan. Our project sponsor was Paul Myers from Spectrum Corp. And our coach was Professor Scott Hawker. So our project was all about the Precision Time Protocol. It's IEEE 1588 v2. The purpose of the protocol is to synchronize computers within a network. It was released in 2008, and there have been 2 versions since then, and they're currently working on the 3rd. It's for Ethernet networks, and the main point of it is it uses special hardware that timestamps that works at the hardware level rather than the software level in order to make accurate timestamps. And it uses messages between the master and the slave devices in order to calculate what the synchronization accuracy is between the devices. So our actual project was broken up into 2 phases. The first one was about setting up a system that uses the Precision Time Protocol to synchronize a network. And the second phase was setting up a system to manage the synchronization across the network and view the synchronization between devices and the components within the devices.
So for phase one, the objective was to create a PTP system utilizing low budget and open source components to find the best synchronization accuracy between the master and its slaves. We weren't necessarily going to be creating a product or delivering the system. The purpose was mainly to research the synchronization accuracy and provide our research to our customer. So we broke this phase up into two prototypes. The first prototype utilized no special hardware components. It was mainly just to analyze the PTP tools and operating systems available for us to use. The second prototype was integrating the hardware timestamping network card and integrating the GPS T-Sync card provided by Spectracom. So the basic layout of our system is very similar to the normal PTP system, where there is a grandmaster that provides time to the slaves throughout the network utilizing PTP. The difference between our PTP system and a normal one is that we introduce a GPS card to the grandmaster, which provides GPS time throughout the network to the slaves. For prototype 1, as I mentioned, it was primarily for analyzing the PTP tools that we would use to get that best synchronization accuracy. We determined that we didn't need to utilize the special hardware timestamping for this prototype because the tools that we were going to be using provided a software timestamp that we could use, as well as software metrics that would allow us to analyze the synchronization accuracy between the master and slave machines. The tools and operating systems that we analyzed during this prototype were Linux PTP, PTPD, Arch Linux, and Ubuntu. The second prototype was, as I mentioned, to integrate the hardware timestamping network card, to integrate the GPS card, and to set up our hardware testing infrastructure. As Brian mentioned, what allows PTP to get as accurate a synchronization as possible is that it timestamps the packet at the hardware level right before it is sent across the network. This is why we integrate the hardware timestamping network card into our system so that we can utilize that feature. We also wanted to get the most accurate results from our system, so we utilized the pulse per second output on the network cards along with the pulse per second output on the T-Sync GPS card to find or to determine the offset between the devices utilizing an oscilloscope. So the deployment diagram for our system shows that the GPS time comes in from the satellite into the T-Sync card. Then the time is set from the T-Sync card to the NIC. The NIC sets the system time. Then the time is sent across the network using PTP4L, and the system time on the slave is set by the NIC utilizing PHC2sys. So the results for prototype 1 and prototype 2 showed that the software tests for prototype 1 produced, on average, a 40 microsecond synchronization accuracy between the master and slave machine. Another interesting result that we saw from prototype 1 was that although we did test multiple PTP tools along with multiple OSs, there was little difference produced in synchronization accuracy. This allowed us to use any of the tools for prototype 2. So, for example, in prototype 2, we used PTP4L and Ubuntu, even though our results from prototype 1 actually showed that PTP4L and Arch Linux was the most accurate. As for prototype 2, utilizing the oscilloscope in our hardware test infrastructure, we were able to test the synchronization accuracy over a crossover cable between the master and slave machine and over a non-PTP compliant switch. The synchronization offset produced between the GPS card and the slave kernel time, as you can see in the middle column, shows that we got a 54.3 nanosecond synchronization accuracy for the crossover cable and a 3044.8 nanosecond synchronization accuracy for the non-PTP compliant switch. These results allowed us to see that we did meet the requirement set forth originally to produce a system that produces a synchronization accuracy below 300 nanoseconds for a crossover cable.
So coming into the second semester, the customer decided they wanted a tool to be able to visualize all the synchronizations of the different clocks in the system. So we wound up needing to develop this management tool, basically a web GUI that would collect the different synchronization accuracies from all the devices and then allow you to view them in a graphical format, as well as be able to, within the system, set alarm conditions to trigger based on whether or not the accuracies are within certain bounds that you set, and also be able to respond if the network does go out of sync just by restarting the devices. So just a quick update to our domain diagram here. We simply we're going to add a manager device in to monitor the switch, and that will ping both the grandmaster and the slave machines and be able to pull those accuracies off the clocks. So going into this semester and getting this project, we needed to make a couple design decisions, the biggest of which was whether or not to go with a custom solution or use existing tools. So there are existing network management tools that exist, and one of them that we found is called LibreNMS, which is completely open source and free. And this, as a backbone, uses the Simple Network Management Protocol, or SNMP for short. And our customer was interested in having SNMP available because this is a standard protocol used by other systems. They'd be able to access the information. If we make our information available in SNMP, not only can you view it in LibreNMS, the sponsor would be able to connect with their own tools and be able to see things. So there were multiple benefits to doing it this way. In addition to it being able to do it faster because we don't have to write much software to do stuff. It's just to get it into the system. The alternative design was to create a custom solution, and we'd wind up just using tools that we're more familiar with, and actually we'd just roll with a simple RESTful APIs across the system. So our plan was to set up a MongoDB instance on each of the agent machines, the machines producing data, and then drop a node instance to expose all the information in that database for querying from the manager computer, and then have a node task that pulls the data off of all the agents, drop that in the database, expose another REST API, which can be accessed by a React application, and then that would allow you to view the data in your system. Having a distributed architecture like this has a couple benefits. For example, the agent database, you could set a little time to expire, right? So you'd store data, and then as you query, you could flush it to the manager if you wanted. You could just have like a much smaller time to expire rate on that, and then have the manager database stored elsewhere at some point, right? So you can store lots of logs, because you're going to wind up with a lot of data, because a lot of this is coming in at 1 hertz. But we sat down with these two options, and these are the main pros and cons. Some of these are already talked about, right? And we wound up looking at this and deciding to go with a open source solution. Use something that already exists. Don't reinvent the wheel, right? Makes sense.
However, this wound up being a problem. We walked down this road for a while, and it was about mid-March, and we really weren't seeing any results. So we've been struggling to get values into Simple Network Management Protocol. We've been struggling to hack LibreNMS to do some of the other features our customer wanted that LibreNMS did not support natively. And so we sat down with our original estimates and put our heads together, brainstormed more realistic schedules. And in the end, what drove the decision to drop what we'd worked on and start creating something completely from scratch halfway through the semester was we felt there was a high risk that we would not be able to produce anything at all if we kept going with where we were, because we were making very little progress. So in the end, we did wind up switching, and Brian's going to go through what we have today for you.
All right. So our product is a web app, so it can be accessed from anywhere. So all you have to do is go to the website. It shows up there. On your first screen with this nice splash screen, our website is named Candy, a PTP management suite. And first thing you're shown are the devices. Right now we just have Mike showing there. That's our manager device. If you want to add a device, you go to the Add Device tab. You type in the name. Here we got Mike. We're going to add Ike. That's Ike-ptp.student.rit.edu. And you click submit, and it's created, so you can go back to the home page, and it shows up there. Then you'll see where it says online. That'll actually change to reflect whether the device is online or offline. And if you go into the device, then that'll bring you to the graph screens. And you have the choices of all the data sources and all the fields for the data that are produced by each data source available. And you can click on one, and then the graphs will show up. And this sort of shows one of the flaws in our design. We didn't get to performance test much, but it actually worked pretty quickly there. So once the graph shows up, it gives you a good visualization of the data, as long as there are no outliers, which we have here. So if you go past it, then you can see what the data actually looks like. It's usually within this range here, with some few outliers there. And this graph library does scale as you zoom in so that you can see the data as clearly as possible. And all of our different data sources are here. They'll show up based on what's available on the device, including the T-Sync and all of its data sources. And it does have the most data sources because it's a pretty comprehensive device with a lot of stuff in it. The other feature we have on here is alarms. So you go to the alarms tab and you'll see all the alarms that have been created. You see what field it's for and a representation of which device it's for. And it'll show you whether they're triggered or not. You can add one by going here. You select the device first, and this is nice because it'll show you only the data sets that are available on each device. So for Mike, you have all 4 of them. For Ike, which is the slave, you only have the couple that are available there. So from this alarm, I'm going to choose PHC2sys and the synchronization field, and it'll be an outside range type, which is for synchronizations. It's good because it'll show you it'll trigger the alarm if it's outside an absolute value. And for the value, I'm going to choose 20 nanoseconds, and I'm going to create it and then refresh the page so we can go back. And you'll see it's not triggered right now, which is good because that means our synchronous it's very accurate. And if there's a spike at some point, it may be triggered when I come back, but no, I guess it's just too good. And that's all we have for that. So back to the presentation. All right, so future work on the site, like I mentioned, the performance testing, we didn't get a chance to work on that with our time frame, and that would be very important as the devices are pulling lots of data and managing lots of data for possibly lots of devices. Graphing non-number values, this would be useful because it would greatly expand the number of values that you can visualize and set alarms for. Expiring data values on agent machines, Kevin mentioned that. That would be so that you don't have the machines filling up with data and breaking. Switching masters, this was something the customer wanted at the beginning of the semester, but after we switched to the other implementation, we didn't have time to implement this. And then additional P2P info, again, like the graphing more values, just enrich the full website. So some of our challenges and lessons learned for people and process aspects. For the second semester, we had one less team member. We had to adjust the amount of work we scheduled ourselves for this and make sure that we accounted for that. And we learned that the guidance from small throwaway prototypes is very beneficial. As we found out from phase 1 with our different prototypes of learning about PTP and how the PTP tools work. And then phase 2 would have been useful if we'd tried to do more of a throwaway prototype with the COTS tools so that we could have figured out earlier how that would turn out. And then for the product and technology aspects, it's hard to list good requirements when you don't have the domain knowledge. We knew nothing about PTP coming into this, and that made it very hard to know what questions to ask the customer in order to figure out what our customer wanted. And that would have been good to know in the beginning. And then the cost of being unfamiliar with a certain set of tools is very significant. Again, with the open source implementation in phase 2. Sometimes taking the less risky path is better, even if it's more work or offers less features, because you're pretty confident that you won't, there's like a set upper limit of how long things will take in that case. Any questions? Yes?
What kinds of applications does this sub-microsecond time stamping of network packets have? I imagine most network packets don't need to be that precisely.
Most don't, but there are a lot of emerging applications, like high-performance stock trading. They're using them in automated cars to make sure they're getting the data in a timely manner and making decisions quickly.
Okay, cool.
So what you do to learn the decision was getting up on board with this, and had you accomplished that, and do you have any insight for another team coming along and trying to learn some of these complex domains?
First thing we did was look at the spec for the standard, and that gave us a basic understanding of the protocol and how it worked. But using the tools, and I think like knowing their applications would have been very helpful in the beginning.
So building those two, we split it up into 2 prototypes, right? So the very first thing we did was install it on some Raspberry Pis and see numbers fly by. And obviously they're way out of range, but that's what got our foot in the door with, oh, this is what is happening here, right? And so then we built another prototype, and a more formal prototype using the software, and went through the process of testing it and getting numbers, right, summing up the values and calculating the averages. And then we added in the component of adding in the GPS card. And then we added in the component of the Ethernet cards. So rather than trying to just do everything all at once, splitting it up into increments and taking that step by step is what let us move quickly in that first phase.
This decision to jump and be able to provide us with a demo. I'm just wondering, in the scramble, did you follow a particular methodology or delegation, or just how did that
Well, we still tried to keep track of risks. Biggest one obviously being changing technologies. Other than that, though, it was like sort of last minute, and we tried to delegate work and break everything up into tasks. But that was pretty much it.
We definitely looked at what the most important requirements were to have like a useful product, if not completing all of them. And then once we knew what like the most important things were, it's really difficult to estimate especially Josh, I think, can talk more about this because he was really in the thick of it. It's really difficult to estimate how long something that you don't understand, how long it's going to take you to understand something that you don't understand. You know, and so this, between research we had done and also winding up seeing lots of testimonials about people, just horror stories with this SNMP protocol from many different people that I've known. I see the audience is laughing as well. It's fairly crufty to work with. And so, as you know, how many weeks did we spend trying to get that working?
3 weeks.
3 weeks? So 3 weeks with no progress, I think, and we just said, you know what, we know what we can accomplish if we do it with the web tools, because we've done this a zillion times before, and I think that was the most important thing. We know we can get this done. We have no idea how much we can get done down this route. Thought that was more important.
So how did you come by SNMP in the first place? Because it is a fairly older protocol, and most anyone who's worked with it is going to tell you it's not the simplest thing. So why did you choose that one in the outset?
Our sponsor asked us to try and use that because it is used in a lot of applications in that field currently. So it would have been useful in integrating with stuff that's already out there.
And it is a standard, so it does make sense. I think we just didn't expect it to be as difficult as it was.
Any other questions?
Let's thank the team.
In this pictures.
All right. How's everyone doing today? We are Team ClassCal. My name's Kevin. I'm joined up here with Hussein, Aziz, and Aaron. And in the audience, we have our faculty coach, Bruce Herring, and our sponsor, Jack Beck. So on the agenda for today, we're going to run through the context of our problem, what the customer, Jack, came to us with. Once we get through that, we'll look into the architecture and the design and what we came up with. We'll show you guys a quick demo of some of the key features that we currently have implemented. Once the demo's over, we'll look into some challenges, what went well, what did not go well, and then we'll wrap up with the future work that we have over the next week, along with the future work of teams going forward. So as I mentioned, Jack, he's the program chair of the School of Film and Animation here at RIT, and being in that role, every semester it is his job and responsibility to create a schedule for the department. So, he has to assign classes to rooms, instructors to classes, and it can obviously be a pretty complex process. So he came up to us with his goal to be able to build a piece of scheduling software that can make this process easier and more enjoyable for him. And obviously you guys are all well aware with SIS and how tedious it can be to go through and enroll for classes and pick out your own schedule. You can imagine that amplified by having to work in schedules for 15 other faculty. And on the bottom here you see an iCal picture, which is what Jack used primarily before, just a regular calendar view. And you can imagine on something like that, being able to try and move one little thing and knowing from that point whether it throws anything else off is pretty much impossible. So you could end up just getting rid of that whole thing and starting from square one if you're using that type of view. So what the customer came to us asking for is something that's simple and easy to use. He wanted the ability to be able to, like I said, quickly edit anything that's currently scheduled, so it's very easy for him to move classes around, move them to different rooms, give them different instructors to fit a good schedule. And then one of the key points is he wanted a new way to view the semester schedule, which, as you'll see in our demo, what we refer to as the blueprint view, was kind of our take and his idea on how to, instead of having a calendar view that is a schedule, you can have this blueprint view, which is based off the rooms and not off like the days of the week. And lastly, he wanted something that was maintainable and extensible, because obviously for this product to be useful for him, he needs to go in every semester and make a new schedule. So you want to make sure that he could use it in that way and use it going forward.
So for our architecture, our application is a 3-layered web app. You see this architecture a lot in industry with web application development. For our presentation layer, we implemented it in React.js with CSS styling, and for navigation, we used React Router so that you can get to the different pages and views of the application without having to refresh the page. For our domain layer, where all of the domain logic is, we implemented that with Python using Django REST framework. REST framework is similar to the standard Django that a lot of us learned, except that it's changed little to specifically create REST APIs. So our domain logic is all contained within that REST API. And for our data layer, we're using a PostgreSQL database to store all of our data, and the REST API interacts with this data layer to store data after it does all its logical operations, and then the presentation layer can then use the endpoints that's exposed by the API to perform operations on the data and get the data and do the various things it needs to function. For our design, the goal of design was to make it as flexible and expandable as possible. Since we are the first team to work on this, we came in knowing that we would not be the only team to touch it, so we wanted to make the future teams that do work on this, give them as much freedom as possible to expand on it, change things, keep things, whatever. We didn't want them to be constrained by the technology choices we made this year. So we know that there's some pretty, there's a fairly grand vision for this project, and wanted to give teams freedom to experiment and meet future requirements that come after us. So to meet this goal, we created an API-powered client application versus
a complete MVC, MV, whatever pattern you see in web application development today. The trade-off with this is that the project as a whole, it's less cohesive. Right now we have two different repositories, one for our front end and one for our back end. They're both deployed independently from each other. So it is less cohesive in that sense, but with our workflow, we thought it was worth it, and again, we believed it was worth it because it just makes the application that much more flexible. If a team wanted to implement a back-end with completely different technology, they had the ability to do that by creating a web service in something like Node or Spring or .NET, and then just exposing more endpoints for the front end to call. Or if they wanted to change out the front end, they could do that and still use the API we created. And now we're going to go into a demo of our application.
So as you see here, the user trying to log in with the RIT authentication. And here we have the blueprint, our home view. And the green rooms are the one available, the red are not. And the gray one, these are the room which is not reservable. The user are trying to pick a certain time and day, looking for a room to reserve. And as you see, as the user picking these times and days, it's a live view. The user here chooses the room. We have the information of the room, clicks on reserve, picking the days, checking the day start, end date, start, end time, the room name, section, and also choosing the course. If it's not new, the user can create a new course. The structure name, schedule the course, and now the room is reserved. We will check in. The room became red, which means it's reserved. Very simple and nice interacting with it. Also, we have an option which is calendar. The user trying to check a room schedule. This calendar has 3 different views: day, month, and week. And if you notice, our calendar is very similar to Apple's iCal, and that was one of the sponsored products. The calendar also, the user can check the structures schedule as well. This is the monthly view, back and forth. They will switching and we're checking the structures calendar.
So yeah, that's when 250 classes when we created earlier. So it's scheduled for 5 for Jack, and then it was also shown in the room, which I think was A145, in which we scheduled the course in.
And finally at home. And we have another option, which is the user can download the schedule of a classroom. And here we have an Excel sheet. Includes all the information about the room.
I'll just end it now.
Okay, so the challenges that the team met, as you saw, the blueprint was the core of this project. And when we started developing this project, unfortunately, we didn't find any available tool to draw an interactive blueprint. Most of these tools were for drawing only. So instead, we choose to work on SVG and draw each room individually based on its coordinate. Another challenge was the RIT authentication because it has a long process until we get their API, meet them, sending them emails back and forth. And finally, the team decided to switch using React in the final phases of part 1. Because when we started the project, the front-end team did everything from scratch. But then we decided to work with React because the back-end team chose to work with Django. And since React and Django work smoothly, we switched it to React. So that took us some time to learn how React works.
So for the parts what went well during the whole year, I'm really glad that actually I work with this team, and I think the rest of my teammates are glad too. We had a good coach, we had a good sponsor too. They were really understanding what we need. They were providing us with every information or pieces that we needed to complete the project. Besides that, we divided the team into 2 small teams. A team worked on the front end and the other team worked on the back end, and that went very good. The other thing is the spiral methodology. When we started, we were not used to it. We didn't know it very well. However, it actually was really a good choice for our project because it was easy to add and change stuff, because this project required a lot of things to do, to change, I mean. Especially when Jack asked us to add stuff or remove or change stuff. This methodology helped us a lot with that. Besides that, we were meeting every week on Tuesdays, and these meetings were really efficient. We could like get a lot of feedback from the sponsor. Besides that, clarifying some requirements that we were not understanding for the spiral in that time. Besides that, each spiral had a week for identifying risks and how to mitigate them, and that was really a good thing because we will know the risks that we will face in each spiral and how to prevent them in case they happen. The last thing is we really enjoyed working on this project. It wasn't easy, it wasn't hard, it was challenging. Making an interactive blueprint based on an original PDF file wasn't an easy thing to do, but at the same time we enjoyed actually making this thing a real thing. So for the part that the things didn't go well, so React, we started late, as Aziz mentioned, and since we didn't use React before, we didn't follow the whole guidelines that we had like on the official React page, and that gave us some problems because we missed some of the stuff because of the small time we had to learn React, so we can switch using it. So that's what is about React. The second thing, bugs found late in development. If we follow the tested plan more closely, that could have helped us prevent actually having these bugs right now. And doing more user testing, because like it's the 4 of us looking at the website the whole time, and Jack and Bruce, so we didn't have like fresh eyes looking at the website, which could have told us about like the bugs we have on the website. The last part is integration. Front end and back end could have done better. Some of the information were missing for the front end team and the back end team. They were not like familiar with the other side, so the front end team was not familiar with all the information that we had in the back end team, and as well for the back end team with the front end team.
Yeah, so for us here with about, I don't know how many days to go, I'm sure someone's counting, we have a few things left we need to do this semester. There's a few features that we've been working on that we were unable to get to that demo there, just time restrictions. We want to make sure they were working well. One of the big ones being the ability to delete and edit courses. we probably have that feature about 95% done, and that'll basically be when you click on one of the rooms that's red, you'll be shown the information of the course that's scheduled, and then you'll be able to remove that course or edit the information about that scheduled course, whether you want to change the instructor or change the room or anything like that. Outside of that, we just need to wrap up we have the ability to create new courses on the fly, but we want to have the ability to create new instructors on the fly. So that'll be added, and then also out of those 2 calendar views we showed you, we're going to add one for a course. So if you want to know when is every section of SWEN 262 this semester, you can look and you can see where each section of each course is scheduled. A few other things we need to work on is a hosting solution. Currently, this is hosted at RIT here on our team account, which is obviously going to die in a sense when our team is done. So we got to prepare to make sure all our code all our code's on GitHub, so we have that ready, but just to discuss with our sponsor what the solution to hosting will be going forward, and then a few documentation things and code cleanup. For the future work, as Aaron I think mentioned earlier, we are the first team that has worked on this project, but Jack obviously has a lot of great ideas and a lot of big plans for the project going forward. First and foremost is the ability to view multiple floors. For the demo, we have the A-level floor of Gannett, which is currently that encompasses all of the rooms that the School of Film and Animation uses. But with the creation or the completion of the Magic Spell Studio being built, the School of Film and Animation is going to be one of the key people to use those rooms. So Jack came to us, Jack wants the ability to implement those floor plans into the software as soon as possible. The next step from there is to be able to have a building view, which, as you saw, we only have like a 2D floor plan view. So you'd be able to look at a building and then dig down into the building and be able to see all the different floors and then pick a floor, and then you'd be at our current level of software. And last but not least, as these guys mentioned, the difficulty we had with creating from a PDF file of a blueprint. So some sort of, I guess, third-party tool that could be constructed to take one of those PDF images and convert it into what our software considers a floor, because a lot of our work in the first semester was just our front-end guys going through and plotting coordinates on these SVG things. Hello, Google. And so they were going through and plotting these and trying to get as accurate of a representation as they could of the floor, but having a third-party tool being built for that sole purpose is something that Jack would like going forward. And I believe with that, does anyone have any questions?
So in terms of when you're adding reservation, obviously when you're viewing a room or a blueprint, you're looking at a specific day of the week. So when you're making a reservation that spans multiple days, was there any thought on how to necessarily represent? Because you could have something that it isn't available on Wednesday.
Yeah.
Wednesday.
Yeah, that came up relatively late. The user testing, the one round of user testing we did on our last spiral, I guess that kind of got brought to our attention of a way to view Monday, Wednesday, Friday's availability for a room. Currently there is no way to do that. You are stuck to a certain date and a certain time. But that being said, based off how courses are, you're not guaranteed that, but you're almost guaranteed that if it's available on a Wednesday when you're doing courses, it's going to be a Monday, Wednesday, Friday. So if it's free on Wednesday, it's probably free on Monday, Friday. So currently nothing for that. Sure.
So you said the separation between front end and back end really didn't work as well as you might have liked. Did you consider doing vertical slices of functionality instead of horizontal dividing up requirements? Or?
I think we might have considered it. If anything, it was just, it's not that it was a bad way to separate it, it's just we may not have done it as good as we could have. If anything, what we needed to improve on was just simply, even if in our weekly meetings, we kind of had an update or I guess a mini session on what the back end guys did or completed, and if they need anything from the front end in order to move forward, and vice versa. If the front end guys, we're trying to call this function, what do we need? What do we need to pass to this function? Stuff like that. So I guess I don't think it was a poor separation. I think it was maybe we just needed to have greater communication between the team in order to make it work better.
Yeah, just to add on to that, I feel like we feel like it was more of a process concern rather than a design concern on our end. So if I were to advise the next team, I would say to put more emphasis on the coordination of the process to fix that.
So one of the buzzwords, if you will, was blueprint, right?
Mhm.
So taking a blueprint. I see that some of your future work, passing the buck, would be that translation of a PDF file. I'm just wondering, to what degree was the process that you followed in order to convert that documented so someone else can benefit from it? And ultimately, in your model, you accounted for rooms as such from a perspective of their dimension, or they're just sort of labeled and plugging or connected to some ID?
Yeah, what you just said at the end there is basically how we implemented it for this one. We realized it's not a very, not the best reusable approach in terms of, if someone wants to go in and add a floor, I mean, they are going to have to go and plot the rooms on a web page and get them to lay out correctly. So it's probably not the best reusable approach. I think there's some documentation available on what you guys went through to get it done. So it's a very tedious process, but that's, I mean, for our, I guess for our requirements, we were only required for the one floor. So while I guess we may slightly hurt another team going forward, we got our one floor in and implemented. I don't know if that exactly answered your question or not.
So there's no spatial understanding from your model as to the geometry range?
Correct.
Let's thank the team.
Hi everyone, we are social giving teams. My name is Kwang. This is Josh, this is Alex, and this is Kai. Our sponsor is Patrick, and our coach is Oliver. So in 2016, people who are over 60 years old are 2 times likely to donate comparing to people who are under 30, as you can see on the chart. There are a couple of reasons. One of the reasons is that they just don't really have enough money to support others than themselves and their families. Another possible reason is that we have different cultural and approach. Different group of people see things differently, and many people don't see the need to donate, or they believe that property cannot be sold, or they just think that their donation is too small to make an impact. So our goal for this project is to provide a solution to attract more people in donations, especially younger people, by making donation more interesting, providing social engagement, and integrating game elements such as the tournaments, point system, and achievement.
So it is really important for us to understand what actually needs to be completed. Since it's phase 2 of the project, we got some code from the other team. They completed some of the models, such as user and non-profit organizations, and they had some functionalities such as sharing things on social media. One of the big requirements for us was to make the website functional. There might be some change in the requirements, so one thing we needed to do for that to happen is to refactor their code to make everything editable by the admin of the website. And of course, we need to complete all the other functionalities. And another goal for us was to make the mobile apps. Ideally, we would make native apps for both iOS and Android. But if that doesn't happen, we at least need to make the UI responsive so it can still be used on a mobile device.
So that's going to bring us into our system architecture and design rationale a little bit here. So everything's very modular. This is kind of a tie over from the first team that worked on this. Every piece has its own little piece of it so that we can separate it out, change things as needed, and make modifications whenever you have to. We talked about this a little bit, but there was a heavy deal of that refactoring that needed to happen. A lot of the stuff that they had written already, a lot of their models were hard-coded to certain information that needed to be manipulated by the admin. So we had to change a lot of the models that were already written, as well as trying to incorporate what they already had into the new models and the new pieces that we were designing. And the customizability by the admin was a big piece of what we did. So we'll show you in the demo how pretty much everything you can imagine on the website can be changed by a non-technical administrator. So as far as our technologies used, we use MySQL for our database, Django and Python for our front and back end, and Stripe for our payment system. And then for communications, we use Trello, GitHub, and Slack for most of our talking.
So these are the features we completed for the website. So the nonprofit organizations can set up days of givings or competitions for the user to take part in. Day of giving would be a dedicated day for the nonprofit organization, and the competitions would be for organizations with the same goal to, quote, compete with each other in a game and then get a portion of the donation. And then the organizations should be able to show their information on their pages. And they can let users learn more about the problems they are trying to solve by showing videos, articles, and even quizzes in the Learning Opportunities page. And after completing those, the users will be rewarded. And the rewards are the achievements, so users can show them in social media. And also philanthropy points, or P points. That's the in-game currency for the site. And they can use to affect the outcome of a competition. And we made some general
improvements on the site, such as the notification for both user and the admin. And also we made the responsive UI so that it can be shown on mobile device. So I'm going to talk about how we managed to meet some of these requirements. So some of the key things we were trying to keep in mind were something such as user engagement, which we accomplished through competitions which nonprofits would compete against each other, and the users can influence who's winning the tournament by using their philanthropy points or directly donating to a side. The users will also be achieving or getting achievements for doing activities on the site, either returning, sharing things, anything that just promotes users engaging with things on the website. Nonprofits can host learning opportunities, which are a way for them to give philanthropy points back out to the users themselves, as well as teach them about their nonprofit. And then the P points throughout the system can influence the competitions. There are some other big things we had here, like we wanted to handle a lot of donations. We had donations coming through the Days of Giving that nonprofits can set up. In the competitions, there will be a donation pool, and everyone who competes in the competition will get a slice of that. It will just depend how much, depending on winning or losing. And of course, there's also direct donations to nonprofits. And a big thing we also were focusing on was redesigning the UI. The last team didn't really consider that part of what they were doing, so it had a very basic form of UI. And we thought that was really important for bringing people back into the site all the time, because if it doesn't look good, you probably don't want to interact with it too much. And for all the payments for these donations, Stripe's handling that. So I'm also going to talk about some of the challenges we faced in this project. So the first, we had some poor design decision handoff from the previous team. They gave us extensive knowledge about what they developed and bugs in the system and like some of their system architecture, but there wasn't a lot of design rationale behind it. So they just didn't really explain everything as well as we wanted them to. And we hope to fix that, and our technical report will include all those things. We did an awful lot of refactoring in this team, or in this project. The previous team, they ended up skeletoning out functions that they did not fully implement and also did not fully design. So because of that, we had to refactor it. We increased the scalability of modules, which was really nice. We weren't able to get to the mobile app. We ended up having to develop too much, and we kind of spent a lot of time developing previous features and refactoring things. So we ended up going with just the responsive design. It was just more in scope than being able to build two apps, since we weren't at the position of building them at the start of the second semester. So we figured that's nowhere near enough time to develop two entire apps. And another big issue we had was we frequently had model changes, and in Django that had error propagation throughout our website happening very frequently. So if you change a field in a model, any page loosely related to that model would generally crash if you didn't know about it. So you might change a field from first name to name, and then you'll have 4 or 5, 6 broken web pages, because Django doesn't fail silently, it fails very loudly. So in the next couple of weeks, as a team, our goal is to deploy the website on the server. The next step is to publish, Ryan publish the admin documentations, which will include all the instructions on how to use the admin site. We also want to release the deployment documentations and also the technical reports. There are several requirements that we have not complete in this phase. So for the next team that take care of this project, they would need to develop a native mobile applications, as well as the mobile API that can talk and connect with the website. And finally, we have developed the P-point system, but it is not connected in our models. So that is what left to be complete.
We're going to show you guys a quick demo if I can figure out how to start it here. That's not the beginning, so let's see if we can restart this. There we go. So we have a user logging in at this point. This is the login screen. Also the create an account screen is in the same situation at the bottom. You can see a new user. We'll take you through that process. We're actually going to pull out the social media login because that was a little bit out of scope after talking to our sponsor. So you can edit all your fields in here. You can change a tag, add a tag, which would be something like clean water, which would be something that a particular nonprofit might be interested in, so you can get information about them. This is the main splash page, and if you're having an event going on, you'll have two different teams, and they'll display what teams are involved, and you can click on either one of those to donate. And at the bottom are days of giving. And if you click to donate, then it brings you right to the Day of Giving donation section, and you can put a donation in through there, which will go directly to that nonprofit. This is a list of the current achievements that are in the system, and that's all modifiable by Patrick, and we'll show you that a little bit later. This is a list of the nonprofits that are currently on the website, so you can scale through. If one thing's interesting, you can click on that, see the information about that, and there's also the donate button there at the top. So we're going to log in as an admin right now and show you the other side of it. And this is the stuff that Patrick will wind up going through, and documentation we need to write for that. This is basically the typical Django admin website, so it's got the entire back end on here. Most of the stuff you won't touch, but things like achievements at the top, competitions, days of giving, nonprofits, they'll be manipulating on a daily basis most of the time. We're going to actually go ahead and create a competition here. And those are the ones that are already in the system, so if you need to, I think I'll show you later, you can open those up. If you're creating a new one, then you basically fill out all the form data. And as we talked about, everything's modifiable, so everything from donation count, you can start with something if you'd like to, donation total if you want to put a pool in the beginning, adding nonprofits here that are already in the system, and then the percentage of the winning team as opposed to the percentage of the losing team. Contenders actually gets populated in the back end, which is the teams that are added earlier. And then the P points you get for donating to the competition will be listed there, and then you pick an end date. And the slug, which is actually the URL for the competition, is shown right there. And then click Save. And now that's in the system. And you can modify it if you need to. And I think I go back and check now we're going to show the Dave. Oh, that was it. Sorry. Any questions?
How
yeah.
does that work in terms of like what's the scope of things that you can set as an achievement, and how does the system implement that?
Pretty much anything. At the moment, they would have to have a coder that if you wanted a new type of achievement. So let's say you wanted an achievement for viewing a friend's page, which doesn't currently exist. You would have to have a coder go through and do the back end as to how to update that. But he can create the achievement itself, the information about it, the amount of P points you get for it, and things like that. There's currently I think it's 9 different types of achievements in there, and if he wants to expand on those, he can create different levels, is what we labeled them as. Each level would have a different benchmark, and when reached, it would give you the appropriate reward for that level. Any other questions?
So you spoke about the last team and the handoff and how atrocious and how difficult it was. There were a couple of good things, but I'm just wondering, aside from your commitment to a great technical report, what are some of the aspects that you feel you're doing well on or you're planning on doing so that the next team doesn't throw you under the bus?
We made it much more expandable. It's a lot more open now. The models can be changed a little bit easier. There's a lot more information that is accessible by Patrick, so that won't need to be changed as much. As well as, honestly, a lot of it's going to be the design pass-off, why we made the decisions we made. There was actually a fair amount of code in hindsight that could have been reused if we'd modified it a little bit, but we had no idea why they used it in the first place, so we didn't understand why it was there. So we wound up taking it out and then realizing later on that it might have been used with a little bit of modification as opposed to rewriting the whole thing. So basically just writing up and telling them why we did the way we did it so that they don't have to do the same thing we did, basically.
And how much of that knowledge is embedded within your code?
So honestly, not a lot of it is embedded in the code, but that was actually by design. They had originally tried to do that, and it didn't work very well for us. So we're leaning more towards making a more explicit design documentation as to why we made those decisions. There is a fair amount of comment in the code telling what this is, what this does, but at the end of the day, when you're reading code, if you know what it does, but you don't know why it fits into the big system, it doesn't necessarily help as much.
Let's thank the team.